Welcome to lecture 35. In this lecture, in this lecture, we will be solving a question that is given to us by a student, and she wants us to solve it a little bit. It's actually an assignment question. Assignment question. So involves a circuit that involves a current source, a voltage source, a resistor, two resistors, a capacitor and an inductor. And what we are supposed to do is to find V1, this node voltage 1 and this node voltage 2 using nodal analysis. So we identify a ground node first, this one, and two nodes V1 and V2. And we already know that we write equation for each node. We'll write equation for node number 1 and then for node number 2. When we write this equation for node number 1, we assume all currents to be moving away from the node like this. And we know that currents moving away from the node are taken as positive. They're written as positive, and the currents entering the node are written as negative. So in this branch, we know that the current is definitely moving towards the node. Therefore, we write it with a negative sign. And for this branch, we don't know the current, so we assume it to be moving away from the node, therefore we write it positive. And for this branch, we don't know the current, therefore we'll assume it to be moving away from the node. So if it is moving away, this means V1 is supposed to be larger than V2. Actually, we don't know what V1, out of V1 and V2, which one is larger. So we write V1 larger if we are writing equation for node number 1, and we'll assume V2 larger if we are writing equation for node number 2. So since we are writing an equation for node number 1, we'll assume V1 to be higher. So therefore it is positive. V1 minus V2. V1 is assumed to be larger. We don't know V1, but we assume it to be larger because we are writing equation for node number 1. Divided by minus J1. The impedance that we find in between is equal to a 0. Is equal to 0 because there is no other current left. So we have written all the negative currents, all the entering currents as negative and leaving currents as positive. So once we solve this, V1 over 1 is a 1, where this minus J1, we already know that 1 over J is minus J. We already know this. And then this means 1 over minus J is plus J. So therefore this minus J, but taken into the numerator, becomes plus J. So this becomes plus J V1 plus V1 plus V1 coming from here plus J V1 coming from here and minus J V1 minus J V2 coming from here is equal to 2 because we have taken this 2 on the other side of the equation. It becomes minus 2. So like this one. And then we'll write equation for the second node number 2. For this node, we'll assume V2 to be larger than V1, so the current will be assumed to be moving in this direction towards V1, from V2 towards V1. So the equation would be V2 minus V1. Instead of V1 minus V2, this would be V2 minus V1, the same numerator minus J1. Then the current in this branch would be assumed to be moving away because we don't know the exact direction, therefore we'll write V2 over J1. And we don't know the direction of the current moving in this direction, therefore we'll assume it to be moving away from the node, and we'll assume that V2 is the largest among all voltages, therefore we'll write V2 minus 12 instead of 12 minus V2. We'll write V2 minus 12 because we have assumed V2 to be the largest voltage in the circuit because we are writing equation for this. So this is the basic concept. Divided by this 1 ohm resistor. So rewriting this minus 1 over minus j1 becomes plus j1, 1 over j1 becomes minus j1, and once we solve this, we reach to a conclusion where we have a plus j1 and a minus j1 terms, they cancel each other, and we are left with minus j1 v1 plus v2 is equal to 12. So this is equation number 2, and this is equation number 1 that we have taken from the last slide. And now we have two equations and two variables. So this is very easy for us to solve because now we have two equations, two variables. So solving this simultaneously as is being left as a homework because it's a part of our assignment. So I hope this will help you solving question number 2 of the assignment. Thank you.